we say thank you to our teacher, Mr. Seto Emono Fenwa, for giving us the laws of indices. Now we want to apply those laws he stated. Now, the thing with mathematics is, first of all, understand the basic concept. That is where mathematics gets easier for us. I oftentimes I see people ponder about mathematics, crying the difficulty in it. Sometimes I tend to find if there's any difficulty in mathematics, and to me there's no difficulty in mathematics. It's just understanding the basic concept. When you get the basic concept about mathematics, you can solve any question any way it comes. That is it about mathematics. So this video, we want to aid people having difficulty in mathematics and other subjects to help them get easy learning. Now, from the laws, we have two practical examples we want to apply, and each of these examples covers all the different aspects of the laws, starting from what? The mathematics, the multiplication law, the division law, the zero index law, the raised to negative law, and even the fractional index law. So these two examples covers all the whole laws. Now let's start. First of all, you have to understand the basic concept of indices. Now you can see from this first example, the base here and the base here are what? Equal, but they are not equal with these ones here. No problem, we can still solve it, but we solve it with the laws at the back of our mind, that we must follow what? The law. Let's start with the first example. Example 1. Example 1. The question says 6 raised to power 2 multiplied by 3 raised to power 0 multiplied by 6 raised to power minus 3 all over 5 raised to power 3 divided by what? 5 raised to power 6. Meanwhile, whatever you do not understand from all what we've taught today, you can send us a message via the YouTube page. Send us a message, your question, and we assure you that we're going to get back to it. We're going to treat it well for you. Now, first in mathematics, you come with your solution, because in mathematics we don't just want to see you get your final answer. When we're marking, we'll mark your steps. It's very important. It's very, very necessary you follow the step. First thing to do now, attack like a lion. A lion attack its prey, right? Now, first of all, you have to attack your first prey. Now, which is your first prey? The numerator here, because this is a fraction. Now, let's attack this numerator here. And the numerator says 2 raised to power what? 6. 6 raised to power what? 2, sorry. 6 raised to power what? 2. Multiply 3 raised to power what? 0. Multiply 6 raised to power what? Minus 3. We want to first of all attack our what? Numerator. So now let me bring back my denominator. 5 raised to power 3 divided by 5 raised to power 6. Now let's attack our numerator first. Look at this numerator. What can we do here? First of all, let's follow our laws. Now, from the third law that says anything raised to power 0 is what? 1. That means this thing here is the same thing as what? 1. That means I can say 6 raised to power 2 times 6 raised to power minus 3 times what? 1. Now, this 3 raised to power 0 becomes my 1 here. Did you get? It becomes my what? 1 here. Then I go to say all over 5 raised to power what? 3 divided by what? 5 raised to power 6. So let's do double attack. We want to do what? Double attack. From our indices laws, the first law says, the multiplication law says, when you have the multiplication between two numbers that the base are equal, you add their powers. Now, look at these two, their base are equal, 6 and 6. What we're going to do is to do what? Add their what? Their powers. So we'll have 6 raised to the power 2 plus into minus 3, then times 1. All divided by, apply it here also, this denominator. We have our what? Division law, which says when the base are equal, you subtract what? Their powers. That means 5 raised to the power 3 minus what? 6. As you can see, 5 raised to the power minus 6. So now let's start. This from our normal plus times minus rule, minus times plus rule. We know that when you say plus times minus, it will give us minus. Why? Minus times minus gives us plus, and minus times plus gives us minus. Plus times plus gives us plus. Now, plus times minus will give us minus. That means we'll be having 6 raised to the power 2, 6 raised to the power 2 minus 3 times 1 all over, now 5 raised to the power what? 3 minus 6 to give us minus what? Minus 3. Yeah, 3 minus 6 will give us minus 3. So now, let's finish up this place here. 2 minus 3 will give us minus 1, is that not? That means we have 6 raised to the power minus 1 times 1 all over what? 5 raised to the power minus 3. Now let's do away with this one. Anything times 1 is still that number, right? 2 times 1, 2. 10 times 1, 10. 20 times 1, 20. So 6 raised to the power minus 1 times 1 will still give us 6 raised to the power minus 1. So we'll have 6 raised to the power minus 1 all over what? 5 raised to the power minus 3. Now, look, this thing is still the same thing as saying 6 raised to the power minus 1 divided by 5 raised to the power minus 3. Yes, it's still the same thing. Now, if you look, the base are not what? Equal. The base are not what? Equal. So we cannot do anything to the powers. Since the base are not equal, we cannot do anything to the powers. We only have to simplify it straight ahead. Now, from our indices law, let's go to this place. From our indices law, the negative power tells us to do what? Negative power says when you have a raised to the power minus 1 is the same as 1 over what? A. Is that not what the negative power indices law told us? That means our 6 raised to the power, therefore, our 6 raised to the power minus 1 all over 5 raised to the power minus 3 is the same thing as 1 over 6 all over, see, my all over is bigger than this one, right? Then 1 over 5 raised to the power what? 3. You can see it, right? And 5 raised to the power 3 gives us what? This is still the same thing as 1 over 6 all over. 5 raised to the power 3 will give us what? 5 times 5, 25. 25 times 5 is 125. So it will give us what? 1 all over 125. Now you can see, right? So now, from this division here, when we want to invert it to multiplication, we will have to invert the fractional denominator. So when we invert this fractional denominator, this division gets inverted to multiplication. Let me show you what I'm talking about. That is 1 over 6 multiply 125 over 1. It has been inverted. Now, this our multiplication, this our division has been changed to multiplication because we inverted this fractional denominator here into this. Now, our final answer gives us what? 125 over 6. We know we cannot leave our answer like this because this is what? Improper fraction. So we have to leave it in what? In a mixed fraction. So if we're going to leave it in a mixed fraction, let's change it to our mixed fraction. If we say 6 into this is 1. Now 6. Go. Okay. Now you know this is in improper fraction, so we have to change it to what? Mixed fraction. And 6 grew into 125. It will give us 20 remainder 5, which is 20 whole number 5 over 6. So if you leave your answer this way, you can still get it. You will get it right, but it's still better you change your answer to mixed fraction. I hope this one is okay. Then let's go start. So with this example now, you can see that we covered almost all the laws that involve in indices from this example here. So you shouldn't get confused about laws of indices. All you should do is just understand the basic concept of every law, then apply it into this. So hit us a message if you have any confusion or where you don't understand or how to apply anyone you try to put your hands or attempt. Hit us a message. We're going to create a video for you and break it down for you. So let's go to the second example. Example 2 says 3 times 128 raised to power 1 over 7 all over 81 raised to power 3 over 4. Now you can see from this example 2 here, that the fractional power law is here, the fractional power law is also here. So we can apply this. Yes, we can apply and solve. So let's start from simplifying this one, simplifying this one. So let's simplify this one. We say 3 times, from our law of that fractional power, we said this denominator will give you the root, while the numerator will give you the what? The power. That is to say, we are going to have the seventh root of 128 all raised to power 1. That's how to represent this here. The 7th root of 1. Mind you, there's a difference between a number like this, 7 roots of 128, and they are not the same. Now you can see that the 7 is on top inside the roots. That means we are taking the 7th root. But this one will take the square root, then multiply by 7. I repeat, this and this are different. Now, this one is telling you to take what? The 7th root of 128. But this one is telling you to take the square root of 128, then multiply by what? 7. So get this difference now. Please get this difference. So now, we'll continue to say this one we can represent it as 81, 4th root of 81 all raised to power what? 3. As the other teacher rightly said, this 4 takes what? The roots, while the 3 takes the what? The power. The denominator takes the root, the numerator takes the what? The power. So now let's look for the 7th root of 128. Definitely it's going to be 2, because when you say 2 times 2 times 2 times 2 times 2. How many places? Times 2. 1, 2, 3, 4, 5, 6 times 2, 7. So let's see. 2 times 2 gives us 4. 4 times 2 gives us 8. 8 times 2 gives us 16. 16 times 2 gives us 32. 32 times 2 gives us 64. And 64 times 2 gives us what? 128. 64 times 2, this is 8, this is 12, 120 what? 8. So definitely the seventh root of 128 will give us what? 2. That means 3 times seventh root of 128, which is 2 raised to the power 7. This is the same thing as 2 raised to the power 7 or raised to the power 1. Then for this one, the fourth root of 81 definitely can't be 2, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 2 cannot give us 81. Then let's try 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So definitely 3 raised to the power 4 is equals to what? 81. So definitely we have the fourth root of 3 raised to the power 4 all over what? 3. So now, the roots inside here, seventh root, can take care of the power inside the root. The roots inside here can take care of the power inside the root. That means this 7 can take care of this 7 to give us 2 left. So we'll be having 3 times 2 raised to the power 1. This 4 will take care of this power in this on this 3 to give us what? 3 raised to the power what? 3. So our final answer is going to be what? 3. Anything raised to the power 1 is the same thing as that number. That is 3 times 2 all over 3 raised to the power 3 gives us what? 27. That means when we multiply, we have what? 3 times 2, 6 over what? 27. So I believe with these few examples you can solve. So I believe with these few examples, okay, first, you know, we can simplify this to the lowest term. When we say 2 here and 3 here to give us 2, why 3 here to give us what? 9. So it will give us 2 over 9. We cannot simplify again. So our final answer should be 2 over 9. So with these few examples, I believe you can solve everything on indices. Everything on indices, no matter how the question is twisted or put, you can solve it. So we're going to put an assignment question for you to take on. Now, we're going to leave you all with a little assignment so that you will practice, because one thing I tell my students back then in my service here is that mathematics is more about practicing. That's mathematics for you. When you want to learn a trade or learn how to sew clothes, make shoe, or learn anything in life, you have to practice. That is the same thing to mathematics. You have to do what? Practices. When you practice, you get acquainted with it. You know how to do it. You know how to navigate your way through any problem. So now we'll leave you with this assignment to practice. The first one is 216 raised to the power 2 over 3 divided by what? 81 raised to the power 3 over 4. It's very simple. Leave your answer in the comment section below the YouTube page. We have 81 raised to the power minus 3 over 4. 81 over 16 all raised to the power minus 3 over 4. And the last one here is 5 raised to the power minus 1 over 2 all raised to the power 4 multiplied by 5 raised to the power what? 3. So acquaint yourself with this little assignment and send us your solutions so we could mark your script for you. Thank you very much. Thanks for staying with us till we get into the next topic called exponential indices.